2.7, we're going to talk about implicit differentiation. This is our last set of notes for this unit. First, I want to mention there's a difference between explicit and implicit differentiation. So, a function in explicit form has y equals x squared plus 3x. My y is by itself, my x's are separate from it, and we can just take our derivative. Okay? So here's what you need to remember as you go through a derivative. Now that you know the chain rule exists, it's actually always there. So the first thing I do here is my power rule. I bring 2 down, I drop the power by 1, we get 2x to the power 1. And then we would multiply by the inside term's derivative. So my inside term here is x, just x, and the derivative of x would be 1. So because what follows is that 1, we really just kind of ignore it. Here, same kind of thing, we have 3x to the first. If we follow along with our power rule, we get 1 times 3 is 3. X is now to the power 0. And then times the derivative of what's inside. So again, the derivative of x would be 1. So you can see that's kind of a waste of our time. However, it's going to help us when we talk about implicit differentiation. This would simplify to x. And this term would simplify to 3 times 1 times 1, or just 3. And that's what we know as our derivative. Okay? Implicit differentiation allows us to find the derivative of a function or not a function. An equation that looks like this. It's not really possible to get y by itself, or not easy to. It's actually easier to take the derivative, how this function is already sitting. Okay, so this is the problems that we will get to in our notes today. We want to be able to take the derivative of this function with respect to x. All right, so that's going to be important. We're always taking the derivative here with respect to x. So not y, but x. Okay. So let's see what happens here in our examples. So first problem, I'm going to have you find the derivative of x squared plus y squared is equal to 100. Instead of having to get y by itself, which would require us to subtract x squared, square root both sides, and end up with y equals plus or minus the square root of 100 minus x squared, and then having to take the derivative, it's actually much nicer to leave it this way, where we're kind of mixed up and don't have y by itself, and take the derivative here. All right, so I'm going to write derivative with respect to x of x squared plus y squared is equal to the derivative with respect to x of 100. So I'm just taking the derivative of each side of my equation. That's it. I'm kind of inserting a derivative on each side. Okay. So using what we know about the chain rule in the first term here, we do the derivative of x squared with respect to x. So I do my power rule first, bring down the 2, and drop the power of x by 1. So we get 2x to the first times the derivative of what's inside. So the derivative of x with respect to x, we know it's just 1, but it's because we're taking the derivative of x with respect to x. So it's dx dx. And this is what simplifies to 1. That's how we get that. Okay. We move on to the next term, and you'll see why this makes sense. Taking the derivative of y squared is the same as taking the derivative of x squared. Well, almost the same. So we bring down the 2 out front, we drop the power of y by 1, and then we follow up with the chain rule, which says to take the derivative of what's inside with respect to x. So the derivative of y with respect to x is y dx. Now, dx is something over itself, 1. dy dx does not simplify, and so this is what we keep, dy dx. And this is actually what they're asking us to solve for. Notice in the problem I said, find dy dx. Find the derivative of y with respect to x. We're solving for this term. So this is what I want to end up getting by itself as I solve this equation. Okay, we're almost done with our derivative. What's the derivative of a constant? Always 0. So we just want to get dy dx by itself. This term has simplified to 1. So I'm going to start by subtracting 2x over to the right. 2y times, and I'll leave this as dy dx, is equal to, subtract 2x over, minus 2x. Okay, and to finish, we'll just divide both sides by 2y. So that leaves us with dy dx is equal to negative x over y. That we've solved for dy dx. Okay, well that was part A. In part B, I'm going to ask you to find the second derivative. So the second derivative of y with respect to x. So it looks like this. My second derivative. So it looks like d squared y over dx squared. Second derivative of y with respect to x again. Okay. What I want to do is take the derivative from where I left off. So to take the derivative here of this guy, what do I have to use on the right side? Because I have a variable divided by another variable. The quotient rule. Okay. So to take the derivative again, we're going to use the quotient rule. So we want to go ahead and pick where we want that negative to go. It either needs to stay with the x or the y. I'm going to go ahead and leave it on top with the x and do my derivative from there. So we have low d high. So the derivative of negative x is negative 1. Okay. Again, chain rule applies. So what's the derivative of x with respect to x? 1. So we could write another 1, but we don't need to. So that's low d high minus high d low. So high, the top term, is negative x times the derivative of the low term. So what's the derivative of y with respect to x? So that would be writing dy dx. Derivative of y with respect to x. That's the derivative of the low term, dy dx. All over the square of what's below, so y squared. So we do need to clean this up, and there's a lot of stuff to do here. You have a negative y, then we have a plus x times dy dx. We can't leave that in the problem. I can't have my second derivative in terms of x and y and the first derivative, whatever it may be. We know what it is. Dy dx is what we solved for. Dy dx is equal to negative x over y. And so we have to make that substitution. Times negative x over y. All divided by y squared. Okay, so more to clean up. Negative y minus x squared over y. All divided by y squared. Okay, so that's kind of nice, although we're not supposed to leave our answer as a complex fraction. We're going to multiply all the terms by the common denominator, y. So So we get negative y squared minus x squared over y cubed. Okay, that seems pretty nice, but I can go a little bit more with this and factor out that negative. And that helps because I know what y squared plus x squared is. It's exactly what we started with. Y squared plus x squared, or x squared plus y squared, is equal to 100. So going back to the very beginning of the problem, make one more substitution. And so we finally end up with negative 100 divided by y cubed. Okay. A little bit more here. I'm not going to ask you to do any more with another derivative for that function, but instead we're going to write the equation of a tangent line here. So what are the two things we need to write the equation of the tangent line? We need a point and a slope. So I already have my point. Now I just need my slope. So remember, slope of the tangent line is given by the derivative. So dy dx, the derivative, was negative x over y. And instead of just evaluating our derivative with its x value, this is in terms of its x and y value. So I need to plug in both values to find my slope. So evaluated at the point 6, 8. So that's going to give me negative 6 over 8, or negative 3/4. And we'll write our equation y minus 8 is equal to negative 3/4 of x minus 6. And we'll just leave that in point slope form. So our last problem here is going to be the one I introduced to you. Find the derivative, find dy dx for x squared plus 2y is equal to x minus y squared. Alright, so the first thing I want to do is show that I'm going to take the derivative of each side. So we're going to write down inserting a derivative on each side of our equation here. Alright, so we have the derivative of the left, x squared plus 2y, is equal to the derivative of the right, x minus y squared. Now we're going to go ahead and take the derivative of each side. So we start with the derivative of x squared. So we bring down our 2, we get x to the power 1, and then we multiply by the derivative of what's inside. So what is the derivative of x with respect to x? Well, it would be dx dx, which simplifies to 1. So I want you to keep thinking about it that way so that you don't forget when you get to any y term, you have to follow up with a dy dx. Okay, and that's important because that's the term we're solving for. So plus the derivative of 2y. So you take your derivative as normal, 2, okay, and then the chain rule follows. Now you take the derivative of y with respect to x, and that's where we get dy dx from. Okay, and that's the left. So now we'll move on to the derivative of the right side. So again, the derivative of x, well, we know it's 1, followed up by the chain rule, the derivative of x with respect to x. That would give us dx dx, which would simplify 1. So I know that feels like we're just writing the same thing over and over. Okay, minus the derivative of y squared. So we do our power rule, minus 2y to the first, followed up by the chain rule. the derivative of the inside, y, with respect to x. So dy dx. So I get another dy dx term. All right, I'm supposed to solve for dy dx, and I have two of them. So to solve for dy dx, we have to find a way to combine these two terms. So what I want to do is always move the dy dx terms to the same side of the equation, and then move anything else that doesn't have a dy dx to the other side of the equation. I'm going to keep 2 dy dx here. We're going to add 2y dy dx over to the left. We're going to keep 1 here on the right and subtract 2x over to the right. So we're almost there. So in order to combine these two terms, you'll notice they're not like terms because they both do not have an extra y term. So the only way to get dy dx by itself is to now factor it out. So of 2 plus y is left. And last step, to get dy dx by itself, we just divide by 2 plus 2y. So 1 minus 2x over 2 plus 2y. And that's our answer.